Hello, xin chào tất cả các bạn. Sorry mọi người bởi vì trễ một chút do một chút sự cố về đường truyền. Thì như các bạn đã biết là sau buổi talk số 1 của Việt Nam Web 3 Test Series Blockchain Chapter về nền tảng toán học, mật mã học, thì các bạn đã nắm được những cái thông tin, kiến thức tổng quan về nền tảng toán học cũng như mật mã học blockchain. Và trong buổi talk số 2, chúng ta đã thảo luận với tiến sĩ Đặng Khánh Hưng về mối quan hệ của công nghệ blockchain với các công nghệ khác cũng như những cái xu hướng ứng dụng của blockchain, đúng không ạ? Và hôm nay chúng ta sẽ tới với một chia sẻ khá là thú vị về Account Abstraction và Chain Abstraction, một cái công nghệ mà theo mình sẽ có ảnh hưởng khá là lớn tới khả năng mass adoption của blockchain. Đó là cái khái niệm mọi người đã biết, khá là nhiều người nghe tới, đúng không ạ, là Account Abstraction, và một cái khái niệm rất mới đó là Chain Abstraction do một cái vị khách mời khá là đặc biệt, đó là bạn Plug tới từ Banyan Collective và cũng sẽ là người đồng sáng lập của Minority Programmer. Bạn thì hoạt động trong giới underground, có nhiều kinh nghiệm trong phát triển những cái ứng dụng và cơ sở hạ tầng trong blockchain. Thì hôm nay cũng có một chút vấn đề nên là bạn cũng sẽ có một chút abstraction, nghĩa là một chút trừu tượng hóa, đúng không ạ? Giống như cái chủ đề ngày hôm nay. Nên là và ngoài ra speaker cũng mang tới một cái hackathon khá là thực chiến với giải thưởng khá là hấp dẫn để các bạn developer có thể tham gia khỏi trải nghiệm dinh thưởng về các bạn ha. Và sau đây thì mình xin mời speaker Mr. Plug lên sân khấu. I would like to invite Mr. Plug to the stage. Yeah, hello. Hello, how are you, Plug?
I'm doing excellent. Really excited to kick off this hackathon and really excited to be sharing some kind of new insights and what we're working on in the near ecosystem, innovating the Web3 space. So thank you so much for having me on.
Okay, thank you so much. So your appearance looks like very abstraction today, like the topic we're discussing, right? So I could like to have some question with you. How long have you been working in Web3?
In Web3, probably first got into Web3, really like into the kind of industry, maybe I would say 4 years now, but using like blockchain and really as an everyday currency for about I think 7 years now.
I see. Yeah, it's been quite a long time. You have a long experience on that, right? And as a developer, so in Web3 everything is new, right? So can you share your experiment to learn new technique like account abstraction, like a chain abstraction, faster and faster, so other developers in our community can have some experience to learn the new technology faster?
Yeah, I mean, one of the things that I really believe in is project-based learning, and not only looking at the documentation, but actually applying it to a real use case that you want to build out. And that's one of the main reasons why we're organizing this hackathon alongside a lot of different other stakeholders in the ecosystem, because we want to actually like a lot of stuff about account abstraction, even chain abstraction, which is this very new concept that really kind of came into the public in back in NearCon in November, is just in theory. So actually putting it into practice, building a use case around it, I think that's what really motivates people to continue building. And yeah, we have prizes, so that's kind of another motivation as well. So that's something I take. Every time I want to learn something, I build a project around it.
That's nice, right? So hands-on experience first, right? Just do it, right? Everything's difficult before it's become easy, so just do it first, right? That's very nice. Okay, I also have received many questions for you today. Để cho mọi người biết thì cái chương trình này mình có bật cái chế độ caption các bạn nhé. Các bạn có thể mở caption để nghe. Nếu mà các bạn không quá cứng tiếng Anh thì các bạn có thể cái caption để nghe các bạn ha, hoặc là các bạn không hiểu gì thì các bạn có thể hỏi lại để xíu nữa mình và bạn Plug sẽ cùng thảo luận để các bạn làm rõ hơn các bạn ha. Thay vì là mình sẽ phải dịch từng từ, bởi vì là thời lượng khá là dài cho cái slide của bạn ấy, nên là mình có bật cái chế độ auto caption, các bạn có thể mở cái caption trên cái YouTube của mình nên các bạn nhé. And I would like to tell you that our audience are mostly deaf and tech people, right? And who are very interested in the new tech. So I hope today you will help our audience understand clearly about account abstraction, chain abstraction, and their roles to support Web3 mass adoption. I know that you prepared to run a hackathon related to this topic as well, right? So I hope that you can share some demonstration to help our audience today how easier to implement a D app with account abstraction and chain abstraction, right? And what kind of idea are potential for them to implement for the abstraction hackathon during your presentation, right? So and now is the stage is yours, and you can start to present about what you bring today for us. Và như mọi người mình đã giới thiệu lúc đầu thì bạn Plug sẽ giới thiệu chúng ta về Account Abstraction, Chain Abstraction và bạn ấy hôm nay bạn cũng là một trong những thành viên của ban tổ chức của một cái hackathon liên quan đến cái chủ đề này với cái giải thưởng cũng khá là hấp dẫn, đúng không ạ? Có nghĩa là ngoài những cái kiến thức chúng ta học thì các bạn cũng có thể tham gia để có thử build, đúng không ạ, thử dev và tham gia cái hackathon để trải nghiệm, để có những cái học hỏi thêm những cái kiến thức mới, kinh nghiệm mới và mang lại những cái phần thưởng về cho bản thân mình và các bạn team các bạn ha. Nên các bạn hãy cùng theo dõi và đặt câu hỏi cho bạn Plug nhé. Okay, Plug, now the stage is yours. You can start your presentation. Thank you very much.
Yeah, so hello everybody. So in today's presentation, first of all, we're kicking off Chain Abstraction Hacks. That's happening in a little bit over a week, from January 8th to 28th. It is an online hackathon, and we kind of have some activations going on all around the world. And for those who don't know what Chain Abstraction means, although it's kind of in the name, I'm going to go over that. I'm going to first kind of go over the kickoff of the hackathon, comparing what you guys might know about account abstraction in the Ethereum space and in other chains, kind of the innovations going on over there, how Near has actually had this account abstraction since day one, and then what are these kind of primitives or these basic building blocks within account abstraction that you can use on Near, and then what is this new idea building on top of account abstraction on Near of chain abstraction, and then kind of going off ideas you can build, going a little bit over case studies in the wild that we already see in the ecosystem, a little bit about the hackathon, and then more kind of details to be released then. And yeah, and then kind of opening up the floor for a bunch of questions. So just so y'all know, if you guys want to follow along, these slides are available at abstracting.org/VBI. Everything here is actually hyperlinked. So if you want to, if you click on these links, you can follow on. This is a resource here. And if you checked also the notes, everything is available here. Yes, all the links mentioned are something that can be referred to. There's also videos for you to help learn. So please go to abstracting.org/VBI and scan this, follow along, click on the links, and hopefully it'll help you kind of ask kind of questions better, and then also come after the fact. And we also have different developer support groups. So if you guys get lost, we can definitely support you out there, and I'm active in all of those. So just going to give you guys a second to look at that. And that's abstracting.org/VBI, where these slides are available. So if you guys don't know what Near is, I know there's a lot of people that may be working in the Move ecosystem, the Polkadot ecosystem, the Ethereum ecosystem. So Near is a low-cost, scalable, and usable layer 1 blockchain built for the open web. And kind of one of the missions that we have is we're an internet where all people control their assets, their data, their power of governance. And we have this narrative of the blockchain operating system and the open web stack that kind of serves as the unified central attention layer for all of blockchain. But this isn't to forget that Near itself is one of the most competitive layer 1 blockchains with 1 second finality, proof of stake, dynamic sharding. So some of y'all may know about Ethereum sharding and its promise to kind of roll out. Near's had sharding from day one, currently with 4 shards, and you can add additional shards to scale linearly. And then also a theoretical 100,000 transactions per second. So highly performant as a base layer 1 in itself. And so here's the registration link. Once again, it's a 3-week hackathon going on. Just another kind of shameless plug over here. So what is account abstraction? Chain abstraction might be new, but you guys might have just now be hearing about account abstraction. And so in the Ethereum space, and if you go here, this is kind of a good explanation by one of my DevRel crushes, Cami, about kind of account abstraction and different types of account abstraction, and what it means in the context of the Ethereum space. I would click on that and give a full dive as well. But I think also a better explanation comes from ZK Sync, which has a variation. ZK Sync is a roll-up on top of Ethereum that also has its version of ERC 4337. And so there are two types of accounts on Ethereum. We're talking about Ethereum. There's externally owned accounts. These are wallets you owned, and then smart contract accounts. The first one, EOAs, or like what you're used to having when you sign up with MetaMask, can initiate transaction, and while the latter one can only implement different sets of logic. And in ZK Sync, they kind of add on top of it. But basically, and I can go here. This is one of the standards that's being heavily adopted when you talk about account abstraction. ERC 4337.io is a great resource there. And essentially, here's a better kind of diagram depicted by Cointelegraph that really outlines what's going on. So one of the biggest hurdles we have with the externally owned account or your own account is that when you create a account, you have to store the private key. You have to essentially get funds to start transacting. Then you got to basically transfer funds into another address, initiate transaction, pay the gas fees, wait for the transaction, confirm the transaction, where like whatever. And so now how these a kind of account abstracted accounts, these smart contract wallets work is that there still needs to be an EOA that signs these transactions. But if you guys are maybe familiar with Uniswap, you kind of have to do one transaction to confirm, another transaction to swap. It essentially allows you to bundle these transactions together into these kind of user ops, and then send it to like a user op mempool, and then bundle these transactions and initiate them all at once. So it essentially allows you to like bundle a series and sets of transactions to really streamline the user experience with these smart contract accounts. And so this allows a lot of possibilities. This allows you to pay for transactions on behalf of users. This allows you to easily kind of create experiences where it's normally one click or maybe even no clicks, where it would be a confirmation transaction multiple times, and it really is not intuitive with currently just EOA. Like the actual like possibilities are endless because you can have an endless amount of user ops or operations that a user can do stacked together, bundled together, and then abstracted away through these smart contract accounts. And so that's kind of like a high level overview. The rise of this as a standard, and if you click here, here's the Dune Analytics dashboard kind of outlining the rise of ERC 4337 accounts. You can kind of see just in the time, there's been over 1 million accounts, and 8 million user operations, and then 6 million transactions. You could kind of see the rise from over this summer. It's only been 6 months, and then actually see the different L2s that have utilized this, with Polygon being a heavy amount of them as well, and then how much they're actually paying, as well as advanced economics. So it's pretty interesting and pretty revolutionary within the past 6 months of what's happening in the Ethereum space, how different L2s are adopting this, and then the providers that are specializing in this. And so this is like, and this is in August, and you saw a lot of the transactions happen in May. Within like the first 3 months, you can kind of see SDKs, software development kits that developers can use that really allow you to easily build within this 4337 framework. You see things that are focused on gaming onboarding. You see infrastructure implementing this, and also smart wallet apps. Some really popular ones are Argent and MBRay, which were really kind of doing MPC and account abstraction before account abstraction was cool. But this all happened in 2023. Except near, just like we had sharding from day one, we also had account abstraction on day one, which is, I believe, 2021. So this is something we've had natively, and it looks a little bit different, actually, kind of a lot bit different, with more kind of usability than you're actually familiar with when you're looking at Web 2, more so than 4337, in my opinion. And so we kind of see, okay, so Near allows you to abstract the blockchain by managing accounts on behalf of users and allowing them to take full custody. We have kind of named accounts. We have the ability that all accounts, all kind of EOAs in our context are also smart contract wallets, where you can program any type of logic onto it without kind of transferring assets from one EOA to a smart account. Like your wallet is inherently a smart contract, which is very powerful. And then the idea of chain abstraction, which not only allows a user to abstract the blockchain, but abstract which blockchain you're interacting with these unified experiences. And I'll go a little bit more into that. And so you kind of saw these wallets, and we had, I think it was 1 million wallets. Even here on, you see kind of already this is actually old. If you look at the top 2 dApps on dApp radars, they're technically abstracted. Kaiching, Sweat Economy, even Play Ember is coming up there. These are mobile applications that abstract and actually create accounts on behalf of users and do transactions on behalf of users. And then because of our account model, you can actually take full custody moving on forward. So at the scale of Ethereum, and even bigger, because these are the top biggest dApps, you already see account abstraction used in the context of consumer-facing applications. So it's very powerful. It's already on practice. And so here are kind of fundamentals. We all have a toolbox with hammers, wrenches, drills. We have an abstraction toolbox, and I kind of wanted to divide it into different concepts. The first one is, I would say, meta transactions. And meta transactions are the ability for you to pay transactions on behalf of users. So instead of you actually needing Near in order to first transact, me as someone who's running a relay or a service, I can actually pay for transactions on behalf of you. Or in specialized cases, say that you have USDC, but you don't have Near, the native gas to transact, I can essentially take that USDC and cover you with Near and kind of have some profitability with a relayer and associated meta transactions. I'll get more into that. Then we have the sub accounts and named accounts. So if you guys are familiar with like the Move ecosystem, Solana, they have like Bonafide with the .sol. They have the SweNS with the .sui. They have ENS that you rent out these .eth domains, and then different wallets essentially map to this. On Near, our actual like account name is a human readable address. So unlike you actually renting and leasing a different account, you can kind of have that natively built in. And then we have the idea of sub accounts where, say, for example, I'm web3plug.near. I can deploy a nft.web3plug.near and essentially like have another account that you know came from this top level domain, which is very similar to the domain and subdomain system that we're used to on the internet. So there's a lot you can do with there that I'll get into as well. There's the idea of function access keys. So access keys that can only be used for gas for particular functions on different contracts. And then there's full access keys, or like kind of multiple private keys in the case of Ethereum. In the case of Ethereum, some of y'all might know you have a private key, not your keys, not your crypto. This is still the case. But if you Google your private key, you can lose your underlying assets. And so if you compromise a private key in the Ethereum space, in the Solana space, you essentially have to transfer all your assets because that has been compromised. On near, you can have multiple private keys, and you can remove private keys with another kind of full access key, as we call it. I'll go more into that. Then we have key palm, which is essentially in the 4337 space, how you kind of saw these user operations bundled together. You can technically automate any type of user on-chain interaction, whether they have an account or they don't have an account, all in one streamlined flow. And also it introduces this concept of on-chain gift cards, which I'll go into. And then there's the idea of message signing, and you guys have this in Ethereum as well. It's basically being able to authenticate that a user essentially kind of owns a wallet without actually signing anything on chain, and that's NEP 413. And then there's the kind of the front end, which we've been heavily emphasizing on the near ecosystem in the past year, of decentralized front ends, the kind of blockchain operating system where you actually store your code on chain. It can be accessed by different clients that run this web engine, and it can actually interact with different essentially chains. And so you can see a one portal where it interacts with different chains. So kind of combining all these things in the toolbox together, where you have automated onboarding and operations through KeyPalm. You have kind of a familiar naming system where you can deploy sub accounts. You can pay for transactions on behalf of users. You can authenticate users. And then you can have these limited access keys based on certain contracts, and an all-in-one unified experience. You really essentially have this open web stack where you can not only abstract the account, but abstract the chain. And so I'm going to go a little bit in. Let me know if you guys have any questions, but kind of a little bit more into these examples. And like I emphasized before, on near, every account is a smart contract. This is built in since day one. And so near's account model, this has a really good explanation and comparison on the near documentation of a comparison. So you might have your public identifier versus the human readable account. You have your secret key, but in this case, you have multiple key pairs and two types of keys, function access and then full access, which is essentially kind of equivalent to one private key. And then essentially you can have these permission key pairs in function access, or you can have these full access keys that can essentially delete each other, or you can add additional and enhance, rotate, or change your password, as we're familiar with in the Web 2 sense. So if you guys are really kind of understanding, this is one of the only blockchains where you can essentially have a username built in, and then you can change your password, which is very familiar with Web 2 applications, and why a lot of kind of Web 2.5 applications are allowed to easily be onboarded. Because say you have a database, you can automatically basically create accounts for all of your users. You want to take full custody? Well, then delete that key, rotate your key, and then actually have full access to your account. And so it provides this kind of streamlined primitives for you to begin to onboard in mass. And this is what happened with Sweatcoin when they last year, when they initiated kind of all their existing user base. They came as a Web 2 application into like Web 3 by creating accounts for all of their users. And so that is kind of a high-level overviews on there. Just to get a sense of what a function access key is, because this in itself is a new concept. And on here, I actually have, there's a bunch of great people who make videos on Near's account model, its keys, and kind of going in depth, playing around with that. So again, follow along on the slides. There's a lot of resources on that. Yeah, let me continue here. And so we have a couple of ways of checking your access keys, which is very kind of unique. And so before you interact with a contract, and actually if I go here, this is one good example. Some people ask this a lot, like, hey, I interact with a contract, it pops up in this Explorer, I'm giving limited permissions to this contract, social.near, for example, and I'm giving a network fee allowance from 0.25 near, but I don't have 0.25 near. And so what this is essentially doing is saying, for a limited function called key, this is essentially basically saying, hey, this contract is authorizing this my wallet is authorizing this contract to spend up to 0.25 in gas, not to transfer anything, not to do anything else, but to just kind of use this allotted amount on this specific contract. So if you go back to in this case, and here's the documentation regarding that, if you go back to this case, you can kind of see one example is in Meteor Wallet, where they actually show all the keys that you've interacted with. So you can actually deauthorize this allowance. But then on Near Blocks, you can actually see whether you have a limited access key or any active full access keys, which serve as full private keys. So essentially, I can look at an account and then see all of the contracts they're interacted with there, which is very powerful as well, and a pretty unique permissioning system that is there. However, a full access key is essentially, and Meteor Wallet, again, shout out to them, they do a really good job of representing this, is these kind of public private key pairs that you can delete. And so actually, if you have an access to a full access key, you can delete another full access key. So the idea of rotating is like say you have one access key, you add another full access key, and then with that one you can delete the old one. And so it's pretty powerful. It's like if I had a key, he had a key, he could delete my key in theory. But that's the kind of idea of rotation. So be very kind of careful on the keys that you add, but you can essentially rotate these keys. And that's kind of the idea of account abstraction kind of natively. But adding to that too is the idea you can actually deploy one smart contract to an account. And here's an example of a near CLI command. And so right now I may just be operating as an account, and there is essentially a way to deploy a WASM file or kind of compiled WebAssembly to an account to specify the smart contract logic on there. And if you want to kind of update the contract, you can essentially kind of redeploy it to the same namespace. You can't put multiple smart contracts on one account. There are some engineers working on it to basically, this is the idea of account extension, to deploy references of different smart contracts to one account. But right now you can only deploy one smart contract. And there's actually adding to that, just how you can have multiple full access keys. If you take out all your access keys, that's a locked account. You can no longer kind of change anything except interacting with that address directly. If you kind of deploy a contract and delete your keys, you can have a locked smart contract account, which is very powerful and can be kind of shown on the Block Explorer. Like, hey, this is a locked account. They can't upgrade this, and it has a lot of implications in the DeFi space. Because knowing this, I could theoretically update a contract if I had a full access key, change the functionality with a locked account. I can essentially have that smart contract there and then lock it and not be able to upgrade.
Okay, thank you, Block. When we pause here a little bit, because some audience not really understand clearly about the account abstraction and chain abstraction yet. So can you slowly explain again about to help on the audience easy understand what's the account abstraction?
So I would say account abstraction is the ability to essentially do a lot of actions, like on-chain actions, to not let the user know that they're interacting with the blockchain, in the context of what account abstraction is generally. In Ethereum, they have a specific ERC 4337.
Okay.
But what this looks like is building smart contracts on top of accounts, paying transactions on behalf of users, and then being able to rotate keys so that in the event that they want to take full custody or completely own their assets, they can very seamlessly. And so that's kind of how the way I look at it is, okay, say, and in the context of Sweat, for example, you'll sign on with your Apple ID, but then they'll make an account on your behalf. And then if I want to take custody of the assets, every time I transact, they'll essentially give me on-chain points, but I won't know that. Under the hood, blockchain is operating. And then the idea I can kind of self-custody of it is kind of like the primitives of account abstraction. So kind of bundling up these on-chain transactions, making it very smooth to onboard, and then also making it very smooth to offboard. But right now, I'm kind of just like giving a little bit comparison of, hey, in Ethereum, we have these externally owned accounts, and then smart contract accounts, and then 4337 essentially allows you to kind of bundle these operations together and then submit it kind of on chain. On Near, we actually have these accounts as native smart contract accounts, and then you can actually deploy smart contract logic on there and then rotate keys as well. And so it's essentially a lot of the things that you're seeing new that happened in the past 6 months, we've already had natively, and then we can kind of use these primitives, these Legos, to build these experiences where people don't know that they're using Near. Chain abstraction is actually building on top of that, and now I not only don't know that I'm using Near, but I'm actually interacting with multiple blockchains with one account under the hood. And so it takes the idea of one blockchain and then kind of multiple blockchains is what chain abstraction is. But I'm kind of going a little bit into like Near's account model, which is a little bit kind of I'll show kind of use cases of
thank you, Plug. I will help audience to understand what you say and to clearly about the definition first, okay, in Vietnamese. So please give me 5 minutes. Ok, mình có hỏi lại speaker về giải thích về Account Abstraction hay là Chain Abstraction để giúp mọi người dễ hiểu hơn, nhưng mà mình tin thì mình nghĩ là cái cách giải thích, cái giải thích của anh ấy cũng vẫn khá là phức tạp, đúng không ạ? Thì thì chúng ta sẽ cùng nhau, mình sẽ dùng một cái khác để mọi người dễ hiểu hơn một chút, đúng không ạ? Về khái niệm về Abstraction hay là nói chung, hay là về Account Abstraction, Chain Abstraction hay là whatever Abstraction sau này các bạn gặp trong công nghệ thì các bạn sẽ hiểu sơ được. Khi mà các bạn chưa có tìm hiểu sâu thì các bạn có thể hiểu được nhé. Ví dụ như các bạn ở đây hầu hết đều là dân lập trình, đúng không ạ? Thì không còn xa lạ gì với lập trình hướng đối tượng, đúng không ạ? Ôn lại một chút về lập trình đối tượng thì các bạn còn nhớ là lập trình hướng đối tượng có mấy thuộc tính không ạ? 4 thuộc tính, đúng không ạ? Thứ nhất là tính trừu tượng, tính đóng gói, tính kế thừa, tính đa hình, đúng không ạ? Thì trừu tượng là một cái khái niệm rất là phổ biến trong thực tế, đúng không ạ? Và cũng là một cái khái niệm rất là cơ bản trong lập trình hướng đối tượng, đúng không ạ? Thì lấy một cái ví dụ về tính abstraction, tính trừu tượng trong thực tế, đó là trong cái việc thiết kế một sản phẩm chẳng hạn, đúng không ạ? Chẳng hạn là một chiếc xe thì nó hoạt động thì nó cần rất là nhiều các bộ phận làm việc, đúng không ạ? Nó có motor, nó có xi lanh, nó có cái cơ chế hoạt động rất là phức tạp, đúng không ạ? Nhưng mà tất cả những cái thông tin, những cái cơ chế hoạt động và thậm chí là kể cả các cái bộ phận bao nhiêu ốc vít trong cái thiết kế của cái xe đó, đúng không ạ? Thì nó không cần thiết với người lái, đúng không ạ? Chúng ta là những người lái, chúng ta không cần thiết. thì người lái chỉ cần sử dụng những công cụ như là bàn đạp này, phanh này, vô lăng này, đèn xi nhan, đúng không ạ? Cửa mở ra mở vào, thế thôi, đúng không ạ? Các cái kỹ thuật phức tạp thì đều được ẩn đi hết khỏi cái trình điều khiển, đúng không ạ? Để chúng ta là những người lái xe thì chúng ta chỉ cần biết những cái chức năng ở phía bên ngoài mà chúng ta tương tác với nó, đúng không ạ? Chúng ta không cần quan tâm đến những chi tiết hay là cách hoạt động của động cơ, đúng không ạ? Thì đó là một cái ví dụ về trừu tượng trong cái sản phẩm thực tế mà chúng ta thấy, đúng không ạ? Nói một cách dễ dàng, một cách cụ thể hơn về khái niệm chung của abstraction, đó là cái việc ẩn đi những cái chi tiết triển khai trong hiển thị những cái gì mà chúng ta muốn hiển thị ra bên ngoài. Hay nói cách khác là người dùng sẽ chỉ cần biết là có thể thực hiện những cái điều gì, đúng không ạ? Là what, và còn cái việc thực hiện ra sao thì chúng ta không cần phải quan tâm lắm đối với những người dùng hay chúng ta là developer, đúng không ạ? Giúp cho đơn giản hóa cái việc sử dụng những cái chức năng của một cái đối tượng nào đó, đúng không ạ? Giảm sự phụ thuộc vào giữa các đối tượng với nhau, đúng không ạ? Và đấy là bây giờ chúng ta áp dụng cái khái niệm về trừu tượng hóa abstraction vào trong cái ngữ cảnh của blockchain, đúng không ạ? Thì bản chất của trừu tượng đó là bản chất của abstraction đó chính là thêm một cái layer đơn giản để chúng ta sử dụng nhằm ẩn đi những cái thứ phức tạp bên trong, đúng không ạ? Quay lại với cái khái niệm, với cái ý tưởng về Account Abstraction trong lĩnh vực blockchain thì các bạn có thể có thể hiểu về cái lịch sử chung của cái account trong Ethereum, đúng không ạ? Với Ethereum thì chúng ta có hai loại account khác nhau, đó là external accounts, EOA, đó là chính là các cái account, là những cái tài khoản, những cái ví mà hầu hết người dùng chúng ta đang dùng, đúng không ạ? Và cái thứ hai là contract account, đúng không ạ? Các ứng dụng, các the app của ai thường dùng, thì mỗi loại nó có cái ưu và nhược điểm chung, nhược điểm khác nhau, đúng không các bạn ha? Thì Account Abstraction là cái lớp mà trừu tượng hóa hai các cái loại account này để user có thể sử dụng một cái loại account có thể tận dụng được ưu nhược của cả hai loại này, đúng không ạ? Ví dụ như là với Account Abstraction, cái lớp trừu tượng này chúng ta có thể tạo ví hợp đồng thông minh sử dụng các cái loại chữ ký xác minh khác nhau, đúng không ạ? Chúng ta có thể tạo ví hợp đồng thông minh bao gồm các cái tính năng như là multi-sign, như là khôi phục mạng xã hội, như là giảm nguy cơ bị mất hoặc là đánh cắp, đúng không ạ? Hoặc là các cái hệ thống bảo vệ quyền riêng tư, đúng không ạ? Hay là xa hơn chúng ta có thể cải thiện hiệu quả cái sử dụng phí gas của các cái protocol, đúng không ạ? Bằng cách là ngăn chặn những cái giao dịch mà chúng ta không mong muốn, hay là chúng ta có thể thực hiện những cái giao dịch hàng loạt batch transaction, đúng không ạ? Ví dụ là ngày xưa thì thay vì chúng ta thì phải thực hiện từng cái giao dịch một, đúng không ạ? Và phải trả phí cho từng giao dịch đó thì rất là mắc. Thay vì vậy thì chúng ta có thể gom lại những giao dịch trên cái ví của chúng ta và chúng ta có thể thực hiện gửi đi một lần nhiều giao dịch, đúng không ạ? Như vậy thì nó có thể tiết kiệm được cái chi phí này, đúng không ạ? Và cái thời gian xử lý, đúng không ạ? Hoặc là một cái ví dụ như là một người dùng thì có thể sử dụng nhiều loại các token khác nhau để trả phí, đúng không ạ? Thay vì bắt buộc phải sử dụng ví Ethereum thì như hiện tại chúng ta thì muốn trả phí bằng Ethereum thì chúng ta phải cần có ETH, đúng không ạ? Nhưng mà với Smart Account thì chúng ta có thể tận sử dụng cái tính năng của Smart Account như là một smart contract để chúng ta có thể chuyển đổi token khác thành cái ETH để trả phí cho cái tài khoản của chúng ta, đúng không ạ? Nó có ích trong cái trường hợp ví dụ như là phân tích một trường hợp ví dụ như là chúng ta muốn chuyển một cái token từ ví mới, đúng không ạ, sang một cái ví mới nào đó, đúng không ạ? Từ một ví cũ sang ví mới, và chúng ta vô tình là chúng ta sẽ gửi toàn bộ các cái lượng ETH từ ví mới trước đó, nên chúng ta sẽ không còn có cái token ETH để trả phí, đúng không ạ? Thì với Account Abstraction, với cách bình thường thì các bạn sẽ bắt buộc là phải có phải chuyển ETH vào cái tài khoản đó để có thể là có ETH để trả phí, đúng không ạ? Phí gas. Và với Account Abstraction thì cách đơn giản là các bạn có thể biến cái ví của chúng ta thành một cái smart contract wallet và cho phép chúng ta sử dụng các cái token có sẵn trong ví để là phí gas, đúng không ạ? Và điều này thì hiện tại thì với ví là EOA thì chúng ta không thực hiện được, nhưng mà sử dụng Account Abstraction bằng một cái lớp trừu tượng hóa và tận dụng các cái tính năng hữu ích của cả hai loại ví đó thì chúng ta có Account Abstraction, đúng không? Thì giúp giúp cho người dùng cũng như là các cái tính năng sử dụng cho người dùng có thể là mạnh mẽ hơn rất là nhiều so với các cái mô hình ví trước các bạn ha. Ok, như vậy là hy vọng là các bạn đã hiểu về Account Abstraction, đúng không? Và tương tự với đấy là Account Abstraction là cái lớp trừu tượng cho về account đó. Chain Abstraction thì mình áp dụng tương tự thôi, đúng không ạ? Có nghĩa là trừu tượng hóa những cái chain để làm sao những người dùng này, những developer chúng ta sử dụng các cái ứng dụng, đúng không ạ, mà chúng ta còn không cần biết là dưới là đó là sử dụng blockchain nào, đúng không ạ? Và không cần biết sử dụng là blockchain nào hay là đang sử dụng blockchain hay là không, thì đó là cái tính năng về Chain Abstraction, đúng không? Cho chúng ta sẽ cùng nghe thử speaker chia sẻ tiếp để chúng ta có thể hiểu sâu hơn về những cái ví dụ của Account Abstraction hoặc là Chain Abstraction như thế nào, đúng không ạ? Ok, cảm ơn. Ok, thank you, Plug, very much. I already help you to explain about the concept with our audience about Account Abstraction and Chain Abstraction, so people can understand. So now you can continue with your presentation.
Yeah, and so really it's like abstracting the blockchain versus abstracting using multiple blockchains. And I'll go a little bit into what chain abstraction means in terms of implementation, but it builds upon a lot of these primitives, a lot of these concepts we're going on here. So I left on the concept of, hey, you can put a smart contract on any account because every account on there is a smart contract. So normally in Ethereum, you would have to basically make sure that exchanges or applications are, detecting multi-sigs as externally owned accounts. We're detecting DAO addresses externally owned accounts. In Near, it's not like that. The compatibility is streamlined because every account is a smart contract, and just like in Ethereum, where you would like lock an account, and like have it non-upgradable, you can easily determine this on Near by deploying a smart contract there and then taking away all the full access keys and showing that, hey, I don't have any full access keys like you saw in the block explorers. I can actually check all the keys, limited access and full access keys. But you can be like, hey, there is no full access keys. It's locked. I can't change it, which is very useful in DeFi applications where you just want to interact with there and you don't want upgradable contracts. So that's the idea of locked accounts. But this also means you can lock yourself out of your own wallet. So don't delete all of your full access keys. And so there's also the idea of storage staking. This is kind of not too essential unless you're using it in your implementation. But on Near, we're actually a data layer, and you can store data directly on chain by staking a certain amount of Near. And so you see now, you may have seen announcements with, a lot of layer 2 rollup as a service actually putting their data on chain as a data availability network, and Near actually being a cheaper alternative to things like Celestia as a data layer because you can store data directly on chain. And you may see on social.near, which I'll go into later, you can actually store front end code directly on chain. So you can really actually like stake an amount of Near for data, which is pretty dope. And then Mario, one of the devs from Orderly, actually has a pretty cool boss component showing there. Then there's the idea of sub accounts, which I was going into. They're like subdomains for your account. So we have named accounts, and you can actually deploy a dot named account there, and you can rotate the keys around an account. So for example, say I was Web3 plug.near, I deployed a sub account NFT Web3 plug.near, then I deployed a contract to that account to mint NFTs, for example. Then I took away all the keys, or I rotated the keys and gave it to someone else. Now you have a sub account you know that I deployed. You know that it's official. It came from Web3 plug.near, but I no longer have access to it, and it's also a smart contract. So since we can only kind of, as of now, deploy one contract to one account, what a lot of us do is say, hey, this is official because it's coming from the top level account, Web3 plug.near, and I have NFT.web3 plug.near. I may have donate.web3 plug.near, but I'm essentially able to create sub accounts of sub accounts of sub accounts where I can use as a wallet. So I can use NFT plug Web3 plug.near to actually buy and transact, or I can just make it a smart contract. But we kind of have this kind of DNS-like structure built into the named account system. So we're one of the unique ecosystems where we actually know the name of our contracts, and we can look it up like they're here. And so here's an example of kind of deleting an account and then also kind of redeploying an account there. And then you see this heavily within the cases of factory contracts, or contracts that make other contracts. So some of you might have seen Sputnik-DAO.near. There is also the idea of actually, like, for example, we have maybe impact.sputnik.near, where that contract deployed the same contract as kind of a factory where we know that contract follows that separate type, but like it's really kind of this bigger contract that deploys other contracts that we use. And so here's kind of another example. Let me escape here. In this example, for example, this is like Genadrop Near is the name of an NFT platform, and they're using a sub account not as a contract, but as a way to actually deploy components under this namespace. So instead of giving kind of people who are developing the actual account, a sub account was deployed, and they're now just managing managing these publishing of these components through the sub account without giving access to the root account. But it's an official component, it's official code coming from Genadrop.near, but it's really the access is limited because the same people who have the Genadrop.near keys don't have the same as the boss.genadrop.near. So this isn't a contract, this is just a regular account, but a contract could be deployed. And so this is kind of allows a lot of things to occur which is pretty cool. And then you can also make it so that the account above also controls the underlying account, or you can kind of completely lose custody and transfer the keys or lock the keys or give them to someone else there. So that's pretty cool and unique, and I'll go into some use cases later. Then there's the idea of key palm. And here we have this idea of link drops. So some of you guys might have been onboarded there. If you guys are familiar with Shardog, they're this essential this software as a service layer that is kind of built on top of link drop. So you may use a Shardog link or link drop link if you already have an account, or if you don't have an account, but then it lets you kind of have these different user ops, these different intents bundled up together and executes there. And so I'll kind of go. KeyPalm has a lot of documentation on there, but they're way more non-custodial than their kind of account abstraction alternatives on Ethereum. And one thing that I really like on KeyPalm is not only can, for example, I can take in user arguments and say, hey, before you have an account, I'm gonna take in these user arguments, and then I'm gonna pass in those user arguments into the operations on chain that I'm kind of daisy chaining or I'm stacking up, and then not only can I like make it so that hey, you claim an NFT, you claim a role in a DAO, you post on your social, and then you kind of claim an account automatically in the same flow. I could also make essentially a trial account, which is a gift card, and I can say, hey, I'm gonna only pay for after you do this for you to use 1 year on this particular contract, and then I can also refund the amount. So normally we kind of have these, hey, free near in this drop. Now we can kind of restrict it and say, hey, you can only use that near here, and if you don't, I can refund it. So it's really this on-chain permissionless gift card. And so there's a lot of stuff you can do on KeyPalm, on-chain surveys, on-chain gift cards, automation into DAO roles, posting and before you even have an account, and this is pretty seamless. And there's a pretty good demo by Matt and Benji, the co-parents at KeyPalm, of them actually going through this trial account and immediately being able to transact before it even asks them to generate a username, and then it generates a username initially, but actually asks them to export the private key after they used a certain amount. So say I want to basically say, hey, you can use the social.near contract for 0.5 near. I'm going to let you have 1 year, but when you use 0.5 near, it's going to basically say, hey, export it now. So you could actually have the user interact before they write down their private keys, which is a really big hurdle. Initially asking someone to write their private keys, to transfer an amount, to interact with all these things and sign these transactions before they even know the value of the product that you're servicing. So KeyPalm allows you to essentially create these experiences before you ask them to do anything else. And this is very similar to like a single sign-on OAuth service when you sign in with Google. And in Web2 applications, they don't ask for transaction fees. So it's essentially kind of like a freemium model. And you can really build this natively and in a non-custodial way, as opposed to meta transactions where you essentially have a relayer and that person is paying for transactions. So this is essentially the most non-custodial way you can kind of build a meta transaction-like experience, which is pretty awesome without setting up a relayer. And I'll go over meta transactions right now. And so meta transactions is the idea of paying for transactions on behalf of users. If you guys have used Aurora did this pretty cool with Aurora Plus, and different services like these account abstraction services on Ethereum. They're basically paying for transactions on behalf of users. So meta transactions allow, essentially, it's the idea of kind of setting up a relay or let's say a server that pays for transactions, specified transactions, and they can even do it for free. Maybe because they want to onboard it and that's a user acquisition cost, or they can do it for profit. And in this example here, in the original Gitbook documentation, it actually gives the example of one of the things that I have a lot is say someone paid me. So a lot of times I will pay people in USDC because it's a stable coin, but they may have created a new wallet, but they don't have enough of the like cryptocurrency or the gas to make any transactions. But I just gave them a fungible token USDC, and so they have this like USDC, but they have no way to swap it to near or transfer it to another wallet because they have no near underlying. And so what this kind of meta transaction example from the textbook is, I can actually not only pay for that person to transact, but I can actually take some of their USDC and then use that to cover the cost for them to swap into near. So there's ways you can profit as a relayer for meta transactions, or you can just pay for transactions, and you can specify the type of transactions you pay for, how much, and you can kind of develop more models for these relayers. And this is very important to realize within chain abstraction, because chain abstraction allows you to basically abstract the experiences on different chains by either fully selling the accounts with the assets in it using near. So say I have Bitcoin and I have a bunch of ordinals or BRC20 tokens on that account. Instead of transferring from one Bitcoin wallet to another, these BRC20 tokens, and paying for gas on that native chain, I can just sell the whole key on near to another kind of near account, and kind of transacted value of Bitcoin from near to near, but not actually interact with gas on the Bitcoin chain. But if I wanted to transfer those native assets, I would actually have to set up a meta transaction relayer to pay for transactions on Bitcoin to transact that. So chain abstraction kind of combines this concept of having relayers, or people who pay for transactions on different chains, in this kind of abstract experience. And I'll go over that later, but it's really important to kind of understand the context of relayers, because it's important. I'll show some applications that use this so you can get a sense of the user experience in the wild here. And so there was a Rust implementation that Pagoda, which was like formerly known as Near Inc., that made. And there's also Luis, one of the head of engineering at Mintbase. He actually created an implementation on Next.js, which is a very popular JavaScript framework on there. So very easy to implement your own relayer to pay for transactions on behalf of users, especially with Next.js. And if you just kind of click there, I'll show the Git book on there, this is just the Rust implementation re-implemented into Next.js. So pretty easy to implement that as well. And so, yeah, NEP 366, we'll definitely go into that and kind of look into the chart and understand how to implement it. We recommend implementing a relayer if you want to do this as well. And then here's another concept, which is a primitive building block that Pagoda also did. It's called multi-party computation. This is not unique to Near. This is the idea of having a key, splitting it up into like sharded keys, and then kind of having an M and N amount of threshold you need to reconstruct the key and then sign with that. So what this looks like in practice, you guys may have used Web3 auth, for example. They'll have a key that is your email, a key that's local storage, and a key that they may have on their own server. And you need two of these three keys to actually generate the full key, the full private key, and transact with that wallet. And so what they'll commonly do is say, hey, like, you have an email service, okay, and then you have your local storage. Those are two of the keys. Now you can transact on it. But say you lose your like local key, you can basically use their key and your key to reconstruct that, and still kind of have this multi-party computation where, like, normally if you would lose a key, you would kind of be screwed. People lose their private keys all the time. The multi-party computation allows for different actors across different devices, so that you can implement an email sign-on, and the email doesn't have full custody there. And so the reason why I bring this up is because in Near, where you actually have multiple full access keys, you can develop a multi-party computation on one full access key, but then you can say, hey, I want to add another full access key and delete the MPC solution. So you can essentially have a full email MPC solution, but then you can be like, hey, I don't trust my email anymore. I don't trust Web3 auth. Let me take full custody, which is very unique in terms of Ethereum, where these MPC solutions are attached to the private key to an account. And in order to transfer those assets, you would have to basically pay gas to transfer everything, that whole identity over, which is very consuming. People don't do it. Now you can essentially take off that email with the same named account, with the same .near, and not have to do any transferring of assets. accounts. The account that you use is the account that you can kind of have this progressive custody solution here. So on here is Pagoda's implementation of MPC recovery, and this is what they use for fast auth under the hood, and I'll go over that. So there's a lot of like easy ways and primitives to work on there, but again, if you go to the slides and you click on that, that goes straight to the GitHub over here. And then message signing is pretty easy to do. It's basically the concept, and then here's the vote from the wallet working group. It's basically a way to verify the owner of an address without actually transacting on chain. So it's a very simple net, but what this allows you to do is say, hey, this person owns that wallet, but there's no transaction needed. So this is also a lot of the case in the Ethereum space, but it's a very powerful tool. And yeah, it's pretty straightforward, and it allows you to one use case that I bring up is I can easily now say, hey, I own this Near wallet, and then I can do a side message on Ethereum. I own this Ethereum wallet, and now I can kind of link these wallets together, and this will help you build a more abstracted chain experience without actually having to have users transact. So you can, in theory, create an Aurora address. You can create a Near address. You can link these together, and then now you know that this associated Ethereum address is associated with another account. So it really comes when you go into the decentralized front ends aspect of things, which is also very powerful. And this is kind of referred to as BOSS, but some people like to refer to the blockchain operating system or the open web stack as all parts of the stack. But I just refer to decentralized front ends as this user-facing layer. And what this is like composable UI. So you can actually store your front ends on chain, this JavaScript-like code, and then you have distribution across gateways, which are client-based applications that essentially run this like web engine code that lets you take this code from on-chain and display it in a composable way. So there are a bunch of different gateways. There's kind of 20 something branded gateways, but anyone can deploy a gateway locally. If you know Urbit, they're kind of like a decentralized, like kind of like computer service. I have a hard time explaining it, but they actually have, they're like a decentralized Raspberry Pi type of network, and they actually have BOSS running locally on all their machines. Some of us use this to deploy link trees. Some of us interface with different DeFi applications by running a gateway locally. But the point is, all these clients, all these web applications that run this web engine actually are able to interpret this code. So when you deploy a code on chain, you actually deploy it across multiple different experiences, and different gateways have different things that they show, but you can actually access the same component across the path of different gateways. So you see here, this is the NDC gateway. I'm able to access this component, which aggregates all the gateways directly from like 3 different gateways, but really it's well over 50 that I know of. And so it's like not only the idea of, hey, the code is on chain, but you can easily access it within other components, build a very composable experiences, and then have distribution where normally like in the case of Uniswap, for example, when they deployed Uniswap, they had fees on the front end. Well, now we're able to basically deploy Uniswap with no fees, distributed across a bunch of different gateways, and when they try to censor us through the front end, they can't really, because I'm not the only one hosting it. It's actually backed up by the Near blockchain. And so yeah, this is the easiest way to get started on building decentralized front ends on here. And then one of the biggest use cases is DApp. So what they did is they essentially aggregated every a kind of L2, and when it comes to swapping, lending, all that type of stuff, and they built a universal entry point, and then they kind of added this airdrop kind of gamified experience. So normally people are bridging their assets, using swaps on here, trying to collect airdrops. What they did is they kind of aggregated every single kind of L2 into one dashboard. So imagine DeFi Llama, but every app actually lives within one application. And then they built this experience into there pretty quickly. If you guys have deployed Uniswap or any kind of DeFi application, it actually takes a long time to kind of set up the whole monolithic repo, but now you can easily deploy the same component onto different chains, aggregate them to one experience, and you can not only access these components directly through DapDap, but you can also create your own gateway or design your own applications pretty easily and pretty rapidly. And so when now it's like in currently DapDap, you're connecting one wallet here, connecting one switching to one network, switching to one network. Where chain abstraction would come in is instead of switching these different networks for these different applications, you would essentially be interacting with one wallet, one chain, and everything happens on the back end. But that isn't necessarily built out, but it kind of depicts this experience here. So this is what I was mentioning with kind of storage staking. You can actually, all this code right here is actually stored on chain, and you can reference other components. So normally when I would want to reference a component, I would have to basically, either reference it through NPM or have it locally. In here, I can actually say, hey, near Vietnam deployed a component, near Vietnam.near deployed a component named, for example, DAO main sidebar. I can reference that component, pass in props, and then build it as part of a larger component. So what this allows me as a developer to do is I'm able to rapidly prototype experiences, multi-chain experiences, and then save it on chain, and kind of build these unique experiences where I don't even have to host it because it's hosted across a bunch of these different gateways. And so that's kind of like a high-level overview of what's going on here. I'll show you kind of a widget of how it looks on near.org. So this right here, everything underneath the sidebar on the nav bar is a component, and it's actually rendering from on-chain. So this right here is an example of okay, so it's actually depending on a component that can't be found right now, which is incorrect. So this is the error that's happening, but actually all of this is a component here, and you can actually fork it directly here. But this code is all stored on chain, and then you can even see like what dependencies on top of other components is being used. But if I go to, for example, near.social, which is another gateway, and so I can actually access this same component, which is designed about showing details about a component here. So it really allows you to essentially compose these experiences that are both multi-chain, and build these kind of custom gateways to reflect that, which is kind of a precursor with all these account abstraction primitives to build chain abstraction, is the main reason why I mentioned that. And so here's kind of the slide I was going over. Really, the high-level kind of overview of what account abstraction versus chain abstraction is. Account abstraction is not knowing that you're using a blockchain, and abstracting experiences. This is make it feel like Web 2, basically. Web 2, you sign in, single sign-on. You don't pay for transactions. You just do what you need to do with your account, and yeah, that's like, it's kind of like the Web 2 experience. But you have a lot of ways to build on top of it. You can bundle operations together using meta transactions, or you can use Keepom. You can have them change their password and their username using Near's account model. You could check whether they are an authorized person using NEP413. But chain abstraction is the idea of, okay, they're not just doing this for one chain, they're doing this for a bunch of chains. And this, in practice, hasn't really been developed in terms of like a major use case. This is kind of being worked on, but I'll show you kind of how to start building that, and a little bit of what that looks like in theory. And so this is an idea of chain abstraction, where the idea of what I was mentioning, a unified UI, which is like the Boss decentralized front ends. Essentially, you have account aggregation, which is the idea of you have a Near account, but then you have sub accounts kind of belonging to this Near account, that essentially for EDSA blockchains. So Bitcoin example, Stellar, Ripple, Arbitrum, all the EVM blockchains are like EDSA type blockchains, where essentially you have these sub accounts controlled by this main account, and you're able to basically transact, and there's basically validators that are that have this kind of relayers for these different chains that you're essentially paying in near, but they are paying for the transactions in native gas for those underlying blockchains. And there's also the idea of the fast finality with eigenlayer, which allows you to basically take like basically transactions that would happen on rollups that would take normally hours or days into a few seconds. But I don't want to go too much into eigenlayer's fast finality, but the underlying concept is you have an account. We use Near's account model to make accounts on behalf of your behalf. And then you pay in Near, but then these NPC validators basically pay for that, pay for those transactions using the Near on the native blockchain. So you're really transacting on one blockchain, but you're interacting with all the other blockchains. But you, instead of going through different apps, you don't really need to, because your accounts are aggregated and all the different apps are displayed under Boss. So this is kind of the overall vision. David Miller has an example on NearCon where he did it here, and there's also a really cool article from Ref Finance on here, and here's kind of the timeline of when this is supposed to kind of come out. There should be an SDK by when Abstraction Hackathon starts on kind of a very early implementation of this, and then validators should be able to implement this within February. And then kind of the chain signatures on mainnet should come out in March. So this is kind of fairly new, but like I think the rest documentation has a better example of how they have like the cross-chain relayers. But that's essentially the high-level overview, and Ryo was emphasizing kind of the relayers for meta transactions initially. So they build up upon a bunch of concepts that I mentioned earlier. But there are ways that you can build this without relayers that I would love for people to experiment on for the chain abstraction hacks in general. And so, and I'll take some time to answer some questions. I'll go in the hackathon. Yeah, there are some hackathon tracks. There's KeyPalm track. There's a meta transaction track. So these are different ways of kind of paying for transactions on behalf of users. One more non-custodial, one that implements relayers, and then relayers are a precursor to chain abstraction. And then there's actually using Boss as another track to kind of unify the front ends so you can build out these experiences there. And then there's general prize bounty. Also, there is a mint-based bounty for those who kind of create quality account abstracted templates. And then there's also a bunch of resources here. We're actually updating this live as well, adding more and more resources here. So that's abstracting.org/resources. And then here's just some case studies so you kind of get an example of like what people are doing in the wild, because kind of everyone has their own implementation. And hopefully this will spark some interest. And I'll go over some initial ideas and then kind of answer some questions. And so some of my favorite examples are Mint-based wallet, which essentially uses meta transactions and that Next.js implementation of a relayer I saw to pay for transactions on behalf of users. FastOff, there's a Telegram wallet, Wormhole Twitter, Here Wallet meta transactions, and then Meteor Wallet. So I'm gonna kind of show you here. So if you guys go to near.org/signup, you can actually see how they use this NPC solution and the relayer to basically create an account using your email and then pay for transactions on the social.near contract. And they have kind of an SDK to build on there. That's pretty cool use case to see. There's the Mint-based wallet, where they actually use passkey to generate a wallet. So normally you guys log in with passkey on maybe your iPhone or your Android device, and it generates a wallet. And then they actually use a proxy minter or someone who pays for transactions to mint NFTs for free. So you're basically signing in with your passkey and then minting for free immediately using the Mint-based wallet. So that's a pretty cool case study. There's also the idea of near names, which allow you to claim a near name and then gift it to a user. So that's pretty cool. I'm going to put the GitHub to this. Also, this is like a pretty OG one. It's basically an easy way to gift named accounts. There's NameSky, which builds on top of this, which allows you to now even sell your whole account, which includes your human readable address, your .near, as an NFT, and this is becoming pretty popular here, which uses a lot of these concepts of Near's account model. So in theory, you can even build an Ethereum smart contract that transacts on near account addresses without even using this chain abstracted meta transaction relayer. Here's another cool one too, by the Wormhole 3 team, that allows you to post using the boss hashtag from Twitter into Near Social. So they basically use meta transactions to be like, hey, every time you post on Twitter, we're basically going to take the Twitter API. You basically sign that, hey, I own this account on Twitter, and I will give you access to post on post on my account on the social.near contract. And then every time they detect with the hashtag boss, they basically pay for that transaction using their own relayer, and then they post it to boss. So if you look at the near.social, you'll see a majority of the posts actually come from this, which is a pretty good way to link Web 2 to Web 3. And in here I have their contracts on here, so you can look into that. Here's an idea of the Telegram wallet, where essentially they make an account on your behalf, and then essentially you can sync your Telegram information into your Near Social profile, where they pay for transactions using the Next.js relayer implementation that I showed you. You can post for free. You can even mint NFTs, and you can transfer assets all for free because they pay for transactions on your behalf. So you're essentially just texting a chatbot on Telegram, but directly interfacing with Near. And one of the, I think the most kind of professional ones is Here Wallet. They've been doing a lot here, where even on Aurora, basically you have a certain amount of points. They pay for transactions on behalf of Aurora, and they actually pay for transactions for Near Social. So in Here Wallet, they have kind of a Web 2 functionality where if I friend you, and like we basically have friend requests, I can accept a friend request from you, I can request a friend request, but if we both accept each other's friend request, what it automatically does on Near Social is it follows them, which is a transaction, but they pay for that on their behalf. So this is a kind of a way that they abstracted this too. And they do something pretty cool too. Back in the past month, Here Wallet just implemented Aurora, and they actually they're able to use your private key from Near to generate an Aurora address as well. So that's pretty dope. But
yeah.
Let's stop for some questions. I've been talking for a while.
Yes, thank you, Plug, for very interesting use cases. Okay, now we just sum up slowly to enable all the audience to understand about your presentation. First of all, which user, what chain abstraction benefit them? Can you tell them in 1, 2, 3 like that?
Yeah, I think there was a tweet yesterday that best exemplifies this. Nowadays, like we have to, if we want to use multiple chains, we have to basically bridge to one chain. We have to get gas on the one chain to another, and then we have to deal with Matic on Ethereum, a Matic on Polygon. There's a lot of room for confusion where we're interacting with different chains, we're interacting with different cryptocurrencies, we're interacting with different dApps, and we're really getting confused on where our assets are, what assets we're interacting with, whether it's the trust applications and so forth. It's already hard enough to interact with one chain, but nowadays there's a new roll-up, there's a new L2, there's a new L1 being popped up like literally every day, every week. And so what Chain Abstraction allows you to do is say, like, hey, let's unify that all into one experience. Let's not worry about which blockchains you're interacting with, and let's make it for the user feel like one experience. So it's basically unifying the user experience of bridging from different chains, transacting on different chains, going to different apps under one experience.
Okay, thank you, Block. So this is the side of the user. So for developers like us, what chain abstraction will benefit them?
Yeah, I mean, a lot of people nowadays, they're not even limited to one chain when they're developing.
Yeah.
Like I know a lot of people in the Vietnamese community. It's like they're like people are working on Polkadot, people are working on Sui, people are working on Near, and then when it comes down to it, like a lot of people want to adopt new chains, so they have to deploy the contracts on a new network. They have to add the new network support, add the respective wallet selectors, and then they have to tell their users, hey, integrate into this bridge over. Like, they're essentially building the same application on different chains. And so what chain abstraction allows you to do is essentially still build on those other chains, but then build an experience where you're actually allowing the assets on the different chains of your application feel connected, and the user, you're only having to onboard once. And that actual onboarding, you can abstract that away with social sign-on. You can make it self-custody. Right now, especially outside of Near, when someone wants to do an email sign-on, that's not really their keys, and they really can't have self-custody. So we're kind of using Near, allowing an opportunity to sign on with traditional sign-on services like you would in Web 2, take self-custody, but also have that one account interact with these different accounts on different blockchains and these different smart contracts. So your user essentially will be able to use your multi-chain application without having to be re-onboarded.
Yeah, so saving a lot of time and the cost, right? Okay, can you come back to the slide 52 about the account chain abstraction in Near? Maybe the architecture slide. Yeah, this one. Yes, this one. Yes. So can you explain again how Alice and Bob create only one Near account, right? And how it can use in multi-chain like a Bitcoin, like a Ethereum, like a Near, like a Solana, or every other blockchain with 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 uh, with chain abstraction here, right?
Yeah.
So of course, Alice and Bob create only Near account, right?
Yeah, and so what this is depicting is this particular example is chain abstraction in the context of a multi-chain ref finance. So ref finance is the leading decentralized exchange on Near, and they're saying, hey, right now we can only interact with Near, but how would we interact with multiple chains? And so this is the idea of the like a cross-chain relayer. So at first, when I showed NEP 366 with meta transaction, I showed the idea of a relayer on Near. Basically, it takes in the form of one payment. In that case, we took in the fungible token USDC, and then we paid for everything in Near. With the cross-chain relayer, what it would be doing is it would say, hey, I'm going to take in Near as a payment, but then I'm going to basically transact on Bitcoin for that amount. I'm going to transact on Ethereum for that amount, and I'm going to or transact on any type of layer 2. So instead of someone bridging their assets and then us giving them that amount of Bitcoin or that amount of Polygon or that amount of Ethereum, what we're saying is, hey, this relayer is basically going to transact that on your behalf, and instead of bridging the amount, it's going to interact with your Near account, which has a Bitcoin account built into one of the sub accounts. So like that, in terms of user experiences, it's like, hey, I have this Near account. There are a bunch of account aggregates. So if you go before, I don't think this presentation does a good job of showing account aggregation. But so like there's this Near account and it says account aggregation. Essentially, this basically has all these accounts under it. And so like when you go back to this, it's like the cross-chain relayer is actually taking in Near as the native asset, but it's paying for those transactions to happen on there, but then you're basically getting it in the native account you have under the Near account rather than bridging it. So it's essentially like you're using one blockchain to pay for the transaction fees on another blockchain with an account that you own under that same account. So rather than you kind of needing a certain amount so rather than me needing to bridge that Near into a Bitcoin and then transact with another Bitcoin account, you're basically saying, hey, this near account has a Bitcoin account. I'm going to pay in near to the relayer. The relayer is going to pay for the transaction on Bitcoin and send the asset to my Bitcoin account.
So the relayer, what is the difference between the relayer and the bridge? Are they the same or they are different in some way?
I would say the relayer is, in terms of messaging, kind of like a bridge, but it's more like the meta transaction relayer, where you're basically taking one asset in and then paying for it's more like a service. It's kind of like a bridge, but not really. It's more of
It
like
means like either standardized way of metadata for messaging in the chain, right? So not just one bridge between the chain, but it is standard way to communicate between, for example, near blockchain and other blockchain.
Yeah, but that's kind of I'm not gonna lie, like bridges do have relayers. That's a thing. Like some of you might know that, like bridges have relayers on here. Yeah. So I would the kind of difference is I think the account aggregation part of things where
Okay.
But in terms of what this looks like, in terms of a cross-chain relayer, and the direct technical implementation of it, that's actually going to come when the hackathon starts, hopefully. So I don't have the exact implementation of what this looks like exactly. Like this is very high-level overview, very early on, but there is a way to implement chain abstraction without a relayer, which is the concept that I was mentioning before. Because right now we're speaking in the context of you actually transferring assets within that chain. You can theoretically actually create a situation where you use, for example, near as a smart contract language, where you create an account on Bitcoin and then you transfer the whole account using a near smart contract, and that doesn't require a relayer. So there's stuff you can do like today without this implementation that doesn't require a relayer. So instead of using a relayer to transfer an ordinal or to inscribe a message saying that an ordinal, a BRC20, is going to have a new owner, you can just say, hey, on near, I'm going to basically, just like I sold an account on NameSky, I'm going to sell a Bitcoin account with all these ordinals that are owned in that account, which wouldn't require a cross-chain relayer.
Okay. Okay. So so you say that the chain abstraction and the relayer is something similar and something different with the bridge, right? So I would like to go deeper with this one by analyzing the cost of the cross-chain transaction. So with the change abstraction, does the cost is similar? Cross-chain transaction is similar to bridge, or is it optimized in some way? Because like many audience here, they concern and ask that because the cross-chain transaction these days is very high, right? Does chain transaction have anything in reducing the cross-chain transaction? In your opinion?
So normally on bridges, I mean, it depends on the bridge, but honestly, I have not seen this actually a cross-chain relayer in this context implemented in practice. So I haven't been able to do a price comparisons. Like for data availability from near to celestial, like we know it's cheaper because we ran comparisons, but the implementation is for the cross-chain relayer isn't out yet. But in the example I said, where you wouldn't be dependent on a cross-chain layer and you would actually sell a Bitcoin account on near, it would be essentially the price of the smart contract interaction on near. But I really don't necessarily know. On a lot of these bridges, you'll essentially be Yeah. I assume it would be a little bit cheaper, but I don't want to speak out of my my
Yeah.
butt, because it like I haven't been able to run any comparisons because we're waiting on the actual
Okay.
implementation.
So it will be released in March, right?
The production grade, but the actual the implementation, the API on testnet, it should be when I was back. Actually, it was there was like an internal implementation release, but we didn't actually before Christmas we did not get the documentation for that, which I was hoping we would for this, to be honest. So we're a little bit
Yeah,
behind.
I got it. Yeah, definitely the user experience is improved really much, right? Because user can use in an application on any chain without awareness of the underlying blockchain, right? And I think the cross transaction fee can be reduced in many ways. For example, like processing the cross chain in the batch, right? Uh, aggregation of the accounts, or aggregating the transaction and do in the one transaction, for example. This is just my guess, right? And later we can see how much the cost for cross chain could be reduced, right? And another audience asked, so currently BOS support only another chain is Ethereum Diab, right? So when it can support most of the chain, uh, so maybe with this architecture and with chain abstraction release, BOS can support multiple chain, right? Is that
Uh,
correct? Yeah.
so I mean, initially, I think the MVPs will be Ethereum, in terms of
Yes.
what you can build. The thing is, you can edit the VM, which or the web engine, which has like Ethers.js and the supporting RPCs to support Ethereum. So you can essentially fork it and add, for example, like the Cosmos.js or Solana.js in there. I mean, you can make a PR to get it added. But as I know right now, I don't think well, Pagoda is working on the implementation that allow external dependencies, but I don't have a clear timeline on that. But
Yeah.
if you are really adamant on adding, for example, Cosmos support or Sui support or you know, Bitcoin support, you can actually add those libraries to the VM and make a PR there, or you can run a gateway where this is supported locally to test out your MVP. So anyone can add it. I have some tutorials we made of how we added like live PR and other external dependencies and different canvases into Boss. So it's possible, but no, I do not think additional chain support will be added. The actual implementation of this will be based on, I believe, Ethereum. But I
Okay.
want to see more Bitcoin functionality. I'm low-key a Bitcoin maxi, and I would love to see more compatibility with Bitcoin. But it's all possible, but I don't want to promise that getting added to the master VM on there. But uh, if you go to github.com/near social/VM, this is the VM, and you can make PRs to this today to get it adopted. So yeah. Oh, and then I'll share kind of a video on how to add external dependencies into your VM.
Okay, but later can you share that with me so I will share that to the community. So it means that it currently in the roadmap by Pagoda, so mostly supporting EVM, right? And possibly Bitcoin. And for other blockchain, the community can develop and add the external dependence to support with BOS by themselves, right?
Yep, they can. So let me just add this to these slides here.
Yeah.
And there's also actually let me add this to. I'm adding some builder groups to the slides,
Okay.
just for some context. So this is the social VM. I'll add that. There is also a near social VM group. So near social VM group. Yeah, I really want Solana and Bitcoin support. Um,
Yeah.
builders.com/tg-social. These are all the relevant groups. So there's build out, which is a lot of bots building. There's keep on, which is there's also mint base for the mint base bounties. This is the near general Telegram. Onboard DAO is also focused on like onboarding solutions, and then near social is on there. So there's a bunch of developer groups on there. Near social would be the best one for social support. But yeah.
Okay, yeah, that's interesting. Okay, I think the community can contribute to add more external dependency to support with the POS, right? Okay, the last question, but also very interesting one is about the unifying trend, right? You present about unifying trend, but one of the important thing is how the unifying security can be achieved for chain abstraction, right?
Yeah, so
Because
that's the idea of account aggregation. And account aggregation is like account aggregation. That implementation is part of is like the MVP for that is going to be as part of that implementation there. So we don't necessarily have it. You can build your own version of it, where essentially you deploy a sub account that essentially has a key that belongs to another chain. But this is this is one of the things that is very
so what technique actually used in the account aggregation?
I would say the closest thing we have on near as of right now is where were the examples in the wild? It's Here Wallet. So Here Wallet, they actually allow you to create an Aurora address with your near seed phrase. So that's like one example of kind of how to kind of unify these accounts. There is an example I've seen before that way back, Solomon Wallet, another deprecated wallet, used where they were able to create a Solana address, a Ethereum address, and a near address using one seed phrase too, where they actually like unified the accounts. But I am still kind of waiting from Pagoda on like what the sub account implementation of that looks like. I've also seen my friends from a wallet on Solana and Ethereum called DreamOS do something similar. But I will kind of send some implementations there. But that's kind of part of the cross-chain relayer and like account aggregation solution that I'm waiting on from Pagoda.
Okay, and I guess that account aggregation use that some technique like ZKP, maybe an application of a ZK proof for account. Yeah.
So yeah, like recently on NearCon, which is like a month and a half ago, like as part of the Polygon chain development kit, Near is like basically building something called ZK Wasm, which will allow us to prove state transitions happening on other chains and is part of kind of the cross-chain relayer to really kind of understand like if something is happening on another chain without kind of the need for a bridge. I'm assuming that's part of the implementation. I don't necessarily know how all this is directly bundled together. I'm kind of waiting on it. But there's a lot of kind of different implementations that can be used. I've seen with unified accounts, what I've seen with meta transactions, and we can do with Boss and Keepom. That kind of will build chain abstracted experiences, but yeah, I don't have an implementation right now.
Yeah, okay, thank you, Plug. I will summarize a little bit about chain abstraction to the community in Vietnamese. So please give me 5 minutes. Okay, để mình giải thích kỹ hơn một chút về chain abstraction, đúng không ạ? Mình có hỏi bạn để giải thích những cái chi tiết hơn để mọi người hiểu về chain abstraction. Thì chain abstraction thì chỉ là cái trừu tượng hóa cái cơ sở hạ tầng blockchain, nghĩa là blockchain và cơ sở hạ tầng nó có thể được ẩn đi đối với user và kể cả với developer, đúng không ạ? Thì chúng ta có thể xây dựng, chúng ta có thể sử dụng những cái app mà chúng ta không cần biết là nó đang thực sự chạy trên chain nào, đúng không ạ? Nó sẽ chạy trên multi chain và cái cơ sở tầng nó được abstract away, có nghĩa là được trừu tượng hóa rồi, và khi đó thì developer họ có thể tập trung vào những cái thứ khác liên quan đến trải nghiệm người dùng, đúng không ạ? Và hầu hết những end user sẽ không cần quan tâm tới những cái cơ sở tầng của the app đó, mà họ chỉ quan tâm đến những cái giá trị của trải nghiệm, đúng không ạ? Nó được thực hiện là thông qua một cái kỹ thuật theo mình hiểu, đúng không ạ? Mặc dù mình hỏi thì Plug không có giải thích rõ, nhưng mình nghĩ là thông qua một cái kỹ thuật đó ZK proof, đúng không ạ? Được giới thiệu những cái hướng tiếp cận mới về security và cho phép một cái máy, đúng không ạ? Một cái máy tính, một cái node có thể chứng minh được nó làm theo một cái rule chung đồng thuận, đúng không ạ? Thì điều này giúp chúng ta có thể là chúng ta có thể chuyển cái focus là từ việc xây dựng một cái share blockchain sang cái cách tiếp cận một cách dễ dàng hơn, đúng không ạ? Nơi mà cái security nó được unify bằng trong cái network thông qua cả sử dụng ZKP, nên chúng ta có thể xây dựng những cái account aggregation hoặc là cái relayer, đúng không ạ? Thì cái unified security này rất là quan trọng trong việc thiết kế lại cái cách xây dựng những the app cũng như là cái hướng tiếp cận về blockchain, đúng không ạ? Thì điều này nó có thể giúp cho chúng ta xây dựng web 3 hay là open web trở nên một cái thể thống nhất hơn, giống như internet ngày nay, đúng không ạ? Chúng ta sử dụng như là một cái một cái platform chung trên toàn thế giới, trên internet chúng ta gặp nhau, thay vì để chúng ta hiện tại thấy là có rất nhiều các blockchain khác nhau. Khi sử dụng the app là một cái ứng dụng nào đó, chúng ta cứ phải suy nghĩ xem là dưới đang sử dụng cái blockchain nào, đúng không ạ? Di chuyển ra sao, kiểu như vậy thì nó giống như là một cái những cái blockchain rất là isolated, rất là riêng rẽ, đúng không ạ? Thì với cái công nghệ này thì nó có khả năng sử dụng cái key là account aggregation, xóa bỏ sự cần thiết phải quản lý rất là nhiều các account khác nhau, đúng không ạ? Ví dụ như là trên cái anh ấy chia sẻ thì trên sử dụng một cái tài khoản nia thôi, đúng không ạ? Thì chúng ta có thể sử dụng trên multi chain, đúng không ạ? Và abstract away những cái account liên quan đến cái tài khoản đó của những cái chain khác thì đã được aggregate sử dụng các cái kỹ thuật mà liên quan đến ZKP, liên quan đến các cái kỹ thuật sử dụng một cái relayer để có thể giúp chúng ta sử dụng một cái tài khoản mà chúng ta sử dụng hoặc là chúng ta sử dụng cái app trên multi chain mà trải nghiệm thì giống như trên một chain, đúng không ạ? Giống như cái web 2 ngày hôm nay, đúng không ạ? Thì đó là những cái điều mình hiểu để có thể giải thích lại cho các bạn. Hy vọng các bạn đã thấy hiểu hơn về Chain Abstraction, đúng không ạ? Thì đây là một cái công nghệ rất là thú vị, đúng không ạ? Để giúp cái trải nghiệm cho việc web 3 nó dễ dàng hơn cho cả việc phát triển lẫn việc sử dụng. Okay, thank you, Plug. I already explained to our community about the Chain Abstraction and how we can get a benefit from that. And return to the hackathon. Can you give some advice on what kind of application, what kind of idea the developer community can make for the hackathon, right? In the topic of the chain abstraction, in the topic of account abstraction. So can you go through again that so people in the community can know what they should do, which topic they can build?
Yeah, and so there's ideas I actually want to see even in near, just as account abstraction, that needs to be built out that I haven't really seen. I'm seeing a lot of these use cases, even though since day one in account abstraction on near, it's just being built out, like meta transactions on Hero Wallet, like the Telegram wallet. So there's stuff that I want to see with sub accounts, deploying kind of factory contracts from named accounts, using Near's private key on and selling it on another chain smart contract account, easily deploying trial accounts on Keepom, building more advanced and robust relayers that take in NFTs or meme coins, being able to easily deploy sub accounts. Right now we do it from the CLI. We have no way to deploy like nft.web3plug.near from like a graphical user interface, let alone interact with another chain. So we have all these primitives built in. A lot of us want us to see this BRC20 support. So we want to see the ability to sell Bitcoin accounts and ordinals through Near, or actually like take like create contracts on Near to basically sell private keys and access to other accounts on different chains. Additionally, I want to see the mapping of accounts more streamlined. I want to see the mapping of Ethereum addresses to Near addresses. One use case, maybe we have a Near social graph. I want to see Near social graph merged with Lens and Farcaster and the ability to link these two accounts. I want to see more integration into Web 2. For example, we saw like Telegram posting, Twitter posting. I want to kind of see this kind of built into more streamlined tools to like interact with traditional Web 2 applications. Yeah, so I also want to see kind of services we can use for developers. I want to see more kind of non-custodial social lot solutions. I want to see kind of solutions where you can kind of use, for example, a NFT on another chain to onboard to a role in a DAO on Near, or have an account on Near easily onboard to a multi-sig on another chain. So kind of experiences that abstract kind of Web 2 functionality and bring it onto Near. Things that continue to build on Near's account model that we haven't seen kind of streamlined application for. Developer tools for easier sign-on services, and then ways to kind of interact with one asset on another chain, and then interact with kind of the onboarding experience of another chain, where it's Near to Ethereum or Bitcoin or vice versa. I'm actually working on all ideas. We'll have a full ideas list on abstracting.org/ideas when it starts on January 8th, kind of exactly on what to build. But before all that, I would highly recommend kind of looking into a lot of these documentation and these case studies and kind of understanding what is there. Also, I would love to see more mobile type of stuff built. I think a lot of the applications that we've seen that are number one, like Swellcoin and Kaching, is like they're mobile-based applications. They use abstraction, but we have no, for example, like an account abstracted wallet built into for like Flutter or React Native, where we can easily kind of create a mobile application that has Near account already built in, or multi-chain accounts already built in. Yeah, in terms of what I'm and all the other judges are grading on, is we're kind of like grading on code complexity, but also like likelihood for other people to fork and use as tooling, likelihood for you to continue as from a project to an actual product. So we have accelerator programs, we have future hackathons. We really want to see you continue to build us out, and then how original the idea is, and then also the user experience, and how like likelihood, how likely someone is able to reuse it. So if you would, I would say the best, I have ideas as well, but the best place to kind of bounce off is all these kind of builder groups, and then just like give a better understanding of like what you want to build, any questions that you have, what's feasible within the time. Yeah, but hopefully that answers your questions. But we have a bunch of DevRel support on all these chats who built a lot of these tools there, so they can kind of help you with the feasibility. Up until January 8th, when we like release all of it, I would really kind of spend time studying and building small link drops, small key palms, small relayer implementations, and then kind of multi-chain experiences on Boss, and just to get a sense of where you're at. But the idea of being started out
very
here.
Nice. That's very nice. I think all the idea and the thing here is a really new thing that can bring the user experience and developer experience to the next level, right? Yeah, many people still very interested in the topic, right? Still, we have like 800 people is follow watching, and I think that's enough information for the community today. And I would like to thank you very much for sharing and discussing. Yeah, and hope that many people will be interested in and can evolve to try to have their hands-on experience with the Chain Abstraction, so that to contribute to the community. Yeah, thank you very much for sharing with us, blog. Yeah.
All right, thank you so much for having me.
Yeah, thank you. Yeah, and Happy New Year too, because I think this is the last time of 2023 we have a discussion here, right? Yeah, yeah. Thank you everyone for attending today, and thank you, blog. Yeah. Bye bye. I would like to stop the live. Yeah, thank you.